Welcome to the Deep Dive. We pull together stacks of really fascinating research and insights, all sourced from the archives right here at the KPP Teen Studio, and we boil it all down for you. The goal is always to give you the most important nuggets, the key takeaways, so you can get well-informed and fast.
Yeah, out through the noise.
Exactly. And today we're tackling a huge topic, one that, well, it affects every single one of us. How to live not just longer, but really, truly healthier.
That's the crucial part.
Right. So our mission today, it goes beyond just, adding more birthdays. It's about adding life to those years, that idea of health span.
And focusing on health span is absolutely vital because, we get so caught up in lifespan, just the number.
Right.
But the reality, especially if you look at, say, the U.S., it's pretty stark. The average American spends, unfortunately, a really significant chunk of their later lives not fully well.
How significant are we talking?
Well, the numbers suggest almost a decade, maybe 9.6 years in actual geatability, or even longer, like 17 years, dealing with poor health, chronic stuff.
Wow. That's a long time to not feel your best.
It's a profound compromise on quality of life, isn't it? So the goal isn't some fantasy of living forever. It's about living well, right up until the end.
Compressing that period of decline.
Exactly. Avoiding those decades of feeling unwell, of being restricted. The real aim is to postpone not just death itself, but all those diseases, those chronic things that usually come with aging, whether they're life-threatening or just, deeply limiting and annoying.
That makes so much sense. And that's exactly what this deep dive is for. We're going to pull out the most important, actionable stuff from all sorts of sources, cutting-edge medical research, clinical studies, timeless wisdom, all curated right here at KPP Team Studio, to empower you, really, with the knowledge to figure out your own path to a vibrant, longer, healthier life. So let's unpack this. Where do we start? Maybe with the basics, the biological blueprint, these horsemen of disease.
That's a great place to start, understanding the fundamentals. And when we look at, what actually causes the most deaths worldwide, and certainly in developed nations, one really stands out.
Okay, when we talk about the big killers, the leading causes, are we talking cardiovascular disease? It always seems to top the list, often called that silent threat. What makes it so dangerous?
You nailed it. Cardiovascular disease is number one. And what's kind of amazing and actually empowering is how much we now understand about the basic mechanism.
Okay.
It really starts small at the molecular level with these things called apolipoprotein B particles, ApoB for short.
ApoB. Okay, what are those?
Think of them like tiny delivery trucks. Their job is to carry cholesterol around in your bloodstream. Now, they have a purpose, but they can also, they can get into the artery wall.
Into the wall itself.
Yes, and while technically they can squeeze in even when the endothelium, that's the super delicate inner lining of your blood vessels, is healthy.
Like a protective layer.
Exactly. But they get in much, much more easily if that endothelium is damaged or compromised in some way.
So it's like a faulty gatekeeper. And once those ApoB trucks get past the gate, it sounds like it triggers a whole cascade, a domino effect. It's not just the cholesterol being there, but what happens next?
Precisely. That's the key. Once those ApoB particles with their cholesterol cargo are trapped inside that endothelial layer, a really critical chemical reaction starts. Oxidation.
Oxidation, like rust.
Exactly like rust on metal. It's incredibly damaging at the cellular level.
Yeah.
And that damage then triggers inflammation. Your body basically thinks something's wrong, like an infection, and sends in the immune troops.
But it's not fighting bacteria.
No, it's fighting that oxidized cholesterol stuck in the artery wall. And this whole thing starts this, devastating cascade of events, and it causes so much structural damage inside the artery wall that you get plaque formation.
The stuff that clogs arteries?
Right. And if that plaque becomes unstable, it can rupture suddenly. And that rupture can cause a clot, leading to a blockage downstream. Blood flow gets cut off. Oxygen doesn't reach the heart muscle.
Yeah.
And that's a heart attack.
And you mentioned those are often fatal.
Tragically, yes. About 50% of the time, the very first heart attack someone has is fatal. It just underscores how critical prevention is. You don't always get a second chance.
That is incredibly sobering. Okay, so if we want to prevent this, if we want to be proactive, what are the biggest levers we can actually pull? Because based on what you just laid out, it sounds like we know how this works. It sounds preventable.
It truly is preventable.
Yeah.
And the evidence for this isn't just, one or two studies. It's overwhelming. It comes from multiple angles.
Yeah.
Rigorous clinical trials, massive population studies, even these clever genetic studies called Mendelian randomization.
Okay.
They all point to the same fundamental things. First, and this is absolutely Critical.
Yeah.
You have to work to reduce your ApoB particles.
Lower the number of those delivery traps.
Exactly. The science is crystal clear. The more of these ApoB particles you have floating around, the higher the chance they'll get into that artery wall and start the whole process. Yeah. We see this direct log linear reduction in heart disease, ASCVD, as ApoB levels go down. It's incredibly consistent.
Hey, less ApoB. What's next?
Second, you absolutely must protect your endothelium, that delicate inner lining. It's your first line of defense.
Right. Keep the gatekeeper strong.
Precisely. So anything that irritates it, weakens it, makes it leaky, that's a problem. The biggest culprits. Smoking is a huge one. It directly damages the endothelium.
No surprise there.
And chronic high blood pressure, just that constant stress on the vessel walls. And then, critically, metabolic issues linked to insulin resistance.
Ah, like diabetes.
Yes. Things like hyperinsulinemia, too much insulin floating around, type 2 diabetes itself, but even just persistently high blood sugar, like in prediabetes. Yeah. Other metabolic byproducts, too, like high homocysteine or uric acid, can also damage that lining.
Okay, so APO down, protect the lining. What's the third piece?
The third piece is managing inflammation. Now, this is a bit trickier because we have fewer direct drugs specifically targeting inflammation for heart disease compared to, say, cholesterol drugs.
Right.
But most of the evidence for lowering systemic inflammation points back to those foundational lifestyle pillars. Really dialing in your nutrition, getting enough good quality sleep, and regular appropriate exercise. These things indirectly but powerfully help create a less inflammatory internal environment.
It really does feel like a bizarre tragedy, doesn't it? Cardiovascular disease kills around 19 million people globally every single year. It's the #1 cause of death. But like you said, it largely doesn't need to be. We know so much. We have the tools. It feels like a solvable problem we're just not solving well enough.
That's a very accurate way to put it. The knowledge is largely there. Implementation is the challenge.
Okay, so you mentioned the horsemen of disease. If cardiovascular disease is the first, what's the next major challenge to our health span?
The next big one, in terms of mortality, would be cancer.
Okay, cancer. How does that compare to heart disease in terms of, say, its underlying causes or genetics?
Well, the genetics are actually quite different. While heart disease can have strong single-gene drivers, like familial hypercholesterolemia, cancer genetics are mostly what we call polygenic, meaning it's usually a complex interplay of many different genes, each adding a little bit of risk.
So not just one bad gene usually?
Not usually. There are exceptions, of course, those well-known ones like BRCA1 or BRCA2 for breast and ovarian cancer, or Lynch syndrome for colon cancer. Those are clear, strong genetic drivers. But for most cancers, even if they seem to run in a family, it's often this complex mix, hard to pin down to one thing.
And what about the environmental factors? We hear a lot about lifestyle links. Smoking and obesity seem to be the really big ones, right? Undeniable links there.
Absolutely undeniable. Smoking is just a profound carcinogen, full stop. And obesity, yes, is clearly driving cancer rates up significantly. Something like 2/3 of cancers show a strong link to obesity in population studies.
2/3? Wow. Is it the fat itself?
That's the interesting part. It's likely not the excess fat tissue, the adiposity itself, that's directly causing the cancer. It seems to be more about the associated factors.
Like what?
Things like elevated growth factors, particularly insulin and IGF, insulin-like growth factor. When those are high, they can basically tell cells to grow, including potentially cancerous ones.
Okay.
And also the increased inflammation that typically comes with obesity. That chronic low-grade inflammation seems to create an environment where cancer is more likely to develop and progress.
So it's the metabolic chaos around obesity more than the fat.
That seems to be the prevailing view, yes. And interestingly, beyond those huge factors, smoking, metabolic health, inflammation, the evidence for many other specific triggers, especially individual foods when calories are matched, is surprisingly inconsistent or weak, despite what you might read in headlines.
Okay, so genetics play a role, environment, especially smoking, and metabolic health plays a big role. But that doesn't feel like the whole picture. Is there another major component in how cancer develops?
Yes, there is. And this is where scientists like Bert Vogelstein have brought in this idea that a significant part of cancer involve, well, what he calls bad luck.
Bad luck. How does luck factor into biology?
Well, think about it. Every single cancer starts with a mutation, an error in a cell's DNA. And most of these are somatic mutations.
Meaning they're acquired, not inherited?
Exactly.
Yeah.
They happen in cells that were originally normal, healthy cells after you're conceived. These mutations can either turn on genes that promote growth on cow genes, like hitting the accelerator, or they turn off genes that normally suppress tumor suppressor genes, like disabling the brakes.
Okay.
While some mutations can be inherited, the vast majority happen during life. The big question is why they happen. And the current best hypothesis, looking at how often cancers occur across different tissues, suggests that random errors during normal cell division, just plain bad luck in the copying process, plays a really substantial role.
So you can do everything right, not smoke, be metabolically healthy, exercise, sleep well, and still potentially get cancer due to these random cellular mistakes.
Unfortunately, yes. That seems to be part of the story. So once you've tackled all the modifiable risks, the things you can control, the next most powerful strategy we currently have is aggressive cancer screening.
Aggressive screening. That sounds proactive, which is good, catching things early. But doesn't aggressive screening also mean you might find things that, well, maybe weren't going to cause a problem, false alarms?
That's a critical point, and you're absolutely right to raise it. There's a definite risk of false positives and overdiagnosis. The harder you look, the more tiny, perhaps clinically irrelevant things you might find, things that might never have actually caused harm or shortened your life.
That sounds potentially stressful.
It can be. You have to go into aggressive screening understanding that trade-off. You have to be willing to potentially deal with the anxiety of a false positive, the follow-up tests, the uncertainty. But if you accept that, it remains a very powerful tool for catching significant cancers early when they're most treatable.
Makes sense. And are there particular cancers where screening is key or where future solutions look promising?
There's a lot of optimism, particularly around improving detection and treatment for what we call solid organ epithelial tumors. That's basically lung, colon, breast, prostate, and pancreatic cancer.
Those are the big ones.
They are. Combined, they account for over half of all cancer deaths. So until we have really effective solutions for those five, we don't truly have a handle on cancer overall. But the progress in targeted therapies and earlier detection methods is genuinely exciting. Things are moving in the right direction.
Okay, so we've covered cardiovascular disease and cancer. That leads us to the third horseman. Neurodegenerative diseases, things like Alzheimer's, dementia. What's the latest thinking there? How does it tie into the others?
What's really striking here is how the narrative is shifting. For decades, the focus in Alzheimer's was almost entirely on amyloid plaques in the brain.
Right, the sticky stuff.
Exactly. Billions were spent developing drugs to clear those plaques with, frankly, very limited success in actually improving cognition or halting the disease.
So the plaques weren't the root cause.
It increasingly looks like they're more of a symptom or perhaps a later stage consequence rather than the primary driver. The emerging understanding is that Alzheimer's, fundamentally, seems to be about inflammation of the brain.
Inflammation again. It keeps coming up.
It really does. Just like with heart disease, where inflammation drives plaque in arteries, and cancer, where it can fuel growth, it seems chronic inflammation in the brain is a core mechanism driving neurodegeneration. It damages neurons, disrupts communication. The plaques might just be collateral damage, or the brain's attempt to contain the problem.
And if inflammation is the driver, are there ways to detect that process earlier, before the damage is done? I've heard about new biomarkers maybe offering a window.
Absolutely. This is probably one of the most hopeful developments. We now have new blood tests, biomarkers like PTA217 for Alzheimer's.
CTA217.
They can often detect the underlying pathological changes decades, literally decades, before someone shows any cognitive symptoms.
Okay, that's incredible.
It's revolutionary because it gives us this huge window for potential intervention. If we can target the inflammation early, maybe we can prevent the downstream damage, the plaque buildup, the neuron loss, before it causes irreversible cognitive decline. It's a massive shift from trying to clean up the mess late in the game to actually preventing the fire from starting.
It's so clear that inflammation is this central, recurring villain across all these major diseases, which perfectly sets up our next topic. The unseen architects of our health, our immune system and our gut microbiome. Let's start with the immune system. I know it changes as we age, right? Something called immunosenescence.
That's right. Our immune system is incredibly dynamic. It's constantly renewing itself, and we're making millions of new immune cells every minute. The whole system turns over roughly every 120 days. But here's the catch. For most people, the quality of those new immune cells tends to decline with age. That decline in function, that aging of the immune system, is exactly what we call immunosenescence. It becomes less effective at fighting off infections, less vigilant against abnormal cells like cancer, and often, paradoxically, more likely to create chronic inflammation.
And we saw a really stark, tragic example of that pre-inflamed state during the COVID-19 pandemic, didn't we? Especially in the US, the outcomes were often worse than in other developed nations. And it wasn't just about age. It seemed linked to this baseline level of immune dysfunction, this inflammaging.
Precisely. The pandemic really highlighted how critical baseline immune health is. That chronic low-grade inflammation, that inflammaging, made people much more vulnerable to severe outcomes, like those devastating cytokine storms where the immune system basically overreacts.
So the immune system isn't just about fighting cold, it's much deeper.
Oh, absolutely. It's arguably one of the most consequential parts of our entire biology. Its dysfunction is implicated in almost every single major chronic disease we face today. Diabetes, obesity, heart disease, cancer, dementia, even things like depression, autism, autoimmune conditions, allergies. The list goes on and on.
Wow.
That term inflammaging really captures it, the idea that aging itself is tightly linked to this increase in chronic, low-grade inflammation, largely driven by changes in the immune system.
And the immune system has different parts, right? There's the adaptive system, the one that remembers things.
Exactly. You have the adaptive immune system, which includes things like B cells that produce highly specific antibodies. It creates immunological memory. Think of them like sophisticated smart palms tailored to specific invaders you've encountered before.
Okay. And then there's the innate system. That sounds older. More basic.
It is the more ancient part, yes. The innate immune system is our immediate first line of defense. It acts incredibly fast, doesn't need prior exposure. It's heavily concentrated in our mucosal surfaces.
Yeah.
Think the lining of your gut, your lungs. And for a long time, the thinking was it was sort of dumb, just the blunt instrument, couldn't learn or adapt.
But that's changing.
Dramatically. Recent discoveries, especially in the last decade or so, have completely flipped that idea. We now know the innate immune system can be taught and trained to be better, more resilient. It exhibits a form of innate immune memory, sometimes called trained immunity, and it can learn surprisingly quickly.
Okay, that's fascinating. How do you train this ancient defense system?
This is where things like polyphenols come in. These are those beneficial compounds found in colorful plants, the deep reds in berries, the greens in kale, the bitterness in dark chocolate or green tea.
The stuff that makes plants healthy?
Exactly. For a long time, they were considered non-essential, but now we understand they play a principal role in priming and modulating the innate immune system. They literally influence which immune defense genes get turned on or off.
So eating colorful plants directly trains our immune system?
In a very real sense, yes. It's an incredibly exciting area, showing this direct link between diet and fundamental immunity. And it's not just food. We're also learning that even some newer medications, like the GLP-1 agonists used for diabetes and weight loss,
like Ozempic.
Right, those types of drugs. They also seem to affect the immune system, partly through their interactions with fat cells. It just highlights this amazing interplay between diet, lifestyle, metabolism, and our immune defenses. It shows that proactive choices, like what we eat, can have a genuinely therapeutic effect, teaching our immune system to be smarter and stronger.
That is a powerful connection. What we eat literally tutors our immune system. And speaking of eating, that leads us straight to the second unseen architect, the gut microbiome. This is way more than just digestion, isn't it? This inner world seems to regulate aging, energy, inflammation, nutrients, immune balance, everything.
It's absolutely central, and the connection to the immune system is incredibly intimate. Get this. A staggering 70% of your entire immune system actually resides in your gut wall.
70%, wow.
Yeah, it's in constant communication, this dynamic crosstalk with the trillions of microbes living just millimeters away on the other side of that gut lining. When your microbiome is balanced and diverse, it sends calming, anti-inflammatory signals to those immune cells.
It's keeping things cool.
Exactly. It helps keep that systemic inflammaging in check throughout your body.
Whoa.
But conversely, if harmful bacteria start to overgrow, maybe due to a poor diet, chronic stress, bad sleep, they can produce inflammatory compounds like endotoxins, particularly LPS, lipopolysaccharides.
LPS, okay.
If your gut barrier is leaky, these LPS molecules can slip through into your bloodstream and trigger a low-grade but body-wide pro-inflammatory state that's linked to so many chronic diseases.
And the link to energy is just as mind-blowing. You're saying gut microbes actually fuel our energy systems.
They absolutely do. They profoundly influence our cellular energy production. Consider studies on germ-free mice. These are mice raised in sterile environments with no gut microbes at all.
Weird.
Totally weird. But they show dramatically impaired development of their mitochondria.
The little power plants in our cells.
Exactly. Our mitochondria, especially packed into cells like brown fat, This suggests gut microbes aren't just supporting mitochondrial function, they might be essential for building these power plants properly in the first place. It underscores how vital that inner ecosystem is for our basic vitality.
So gut microbes build our power plants. That's incredible. And what about the gut-brain connection, the gut-brain axis? That sounds like a direct line.
It absolutely is. It's a crucial two-way communication highway, and the main cable is the vagus nerve. Interestingly, about 80% of the signals traveling along the vagus nerve go from the gut to the brain, not the other way around.
So our gut is constantly talking to our brain.
Constantly. What's happening in your microbiome is literally shaping your mood, your cognitive function, your stress resilience. Certain gut bacteria even produce neurotransmitters directly, like GABA, which helps calm anxiety.
Bacteria making brain chemicals.
Yes. And get this, over 90% of your body's serotonin, the key mood-regulating neurotransmitters often associated with happiness, is actually produced in the gut, heavily influenced by your microbes, not primarily in the brain.
90%. That explains a lot about gut feelings.
Yeah, it really does. It directly impacts mood, focus, resilience, anxiety levels. It's profound.
And it doesn't stop there. Nutrient absorption, too. How do microbes help with that, especially as we get older?
They are absolutely essential. Our own digestive enzymes can only break down so much. Gut bacteria possess enzymes we lack, allowing them to break down complex carbohydrates, fibers, and even some polyphenols into forms our body can actually absorb and use, making them bioavailable.
So they unlock nutrients for us.
Precisely. This becomes even more critical as we age because stomach acid production tends to decline, making initial digestion less efficient. Bacteria pick up the slack. They're particularly crucial for producing short-chain fatty acids, or SCFAs, like butyrate.
Butyrate, I've heard that's important.
It's a superstar molecule. Certain bacteria, like Ficalibacterium prausnitzii and Eubacterium howlei, are amazing butyrate producers. Butyrate is the primary fuel source for the cells lining your colon. It helps heal a leaky gut, it lowers systemic inflammation, and it even supports mitochondrial biogenesis, helping your cells build more energy factories.
Wow. So specific bacteria are like little longevity factories inside us. Are there others, like butyrate producers, that are particularly linked to health span?
Oh, definitely. One that's getting a ton of attention is Akkermansia mucinifila.
Akkermansia, okay.
This one is fascinating because it actually lives in the protective mucus layer lining your gut. It helps strengthen that crucial barrier. And study after study shows that higher levels of Akkermansia are linked to better insulin sensitivity, improved metabolic markers, even in people who are overweight but eating the same calories.
So it helps metabolically even without weight loss.
It seems so. It's even been linked to better responses to certain cancer immunotherapies, which is incredible.
That's wild.
And get this, there's a specific piece of Akkermansia, a protein fragment called P9, that, when isolated, has been shown to trigger your own body to secrete more GLP-1.
GLP-1, that's the hormone those weight loss drugs mimic, right?
Exactly. The same powerful hormone involved in appetite control, insulin sensitivity, and fat burning. So this little bacterium living in your gut lining can naturally nudge your body to produce more of this beneficial hormone. It's a beautiful example of how our internal ecosystem supports us.
Okay, this is all incredibly compelling. We definitely want more of these beneficial microbes like Akkermansia and the butyrate producers. So how do we actually cultivate them? What foods should we be eating?
That's the practical question, right?
Yeah.
Thankfully, there are lots of great food choices. Pomegranate is fantastic for Akkermansia. It contains unique compounds called alagitannins that specifically feed it.
Pomegranate? Okay.
Chili peppers, black raspberries to it at. They have different polyphenols that act as prebiotics for beneficial microbes. Resistant starches are another key category.
What are those?
Think cooked and cooled potatoes, day-old rice, green bananas. The cooking and cooling changes the starch structure, so it resists digestion in the small intestine and travels down to the large intestine to feed your microbes.
Like microbe food.
Exactly. And then you have classic prebiotic fibers found in things like leeks, asparagus, garlic, onions, oats, excellent fuel for butyrate producers, and Akkermansia. Don't forget omega-3 fatty acids, flax seeds, chia seeds, walnuts, fatty fish like salmon. They help reduce overall inflammation, creating a better environment for good bugs. And of course, fermented foods. Things like kefir, yogurt with live cultures, sauerkraut, kimchi, kombucha. These directly introduce beneficial live microbes into your system. Variety is key.
It really sounds like building a diverse garden inside you. You mentioned a gut-primed meal strategy earlier. Can you walk us through that? How can someone apply these ideas practically?
Yeah, it's a simple but really effective approach to optimize digestion and get those microbial signals working for you. First, try starting your day, or maybe even each meal, with a small serving of something fermented or fiber-rich.
Like a little kickstart.
Exactly. A spoonful of kimchi, maybe some yogurt, or even just a few olives. It primes the gut, wakes up digestive enzymes. Second, mindful eating. Eat slowly, chew your food really thoroughly.
Mom was right.
She absolutely was. Chewing sends important signals through the vagus nerve to your brain and digestive system, enhancing enzyme release and gut movement. Third, try pairing fiber with healthy fats.
Like lentils with olive oil.
Perfect example. Or avocado on whole grain toast. This combo slows digestion, helps you absorb fat-soluble vitamins better, and provides sustained energy while feeding your microbes. And lastly, hydrate between meals, not so much during meals.
Why's that?
Drinking a lot of fluid with your food can dilute your stomach acid, making it less effective at breaking down proteins initially. So sip during meals if needed, but do most of your hydrating between them. These small, consistent habits can really shift your gut environment towards resilience and anti-inflammation.
Okay, that's super practical. So all this understanding the horsemen, nurturing our gut and immune system, it feeds into these bigger pillars of action for health span. Let's talk nutrition. We hear about it constantly, but it still feels so confusing sometimes. What's the real core issue?
You know, for most people in the modern world, the single biggest nutritional challenge isn't deficiency, it's excess. Specifically excess energy or overnutrition.
Too many calories.
Fundamentally, yes. Our bodies evolved over millennia in environments where calories were scarce and unpredictable. So we became incredibly good at storing energy, mainly as fat. That was a survival superpower. It fueled our big brains.
Right.
But now, in our current environment, with hyper-palatable, calorie-dense food available 24/7, that superpower has become a massive liability. This chronic energy surplus is arguably the root cause, or at least a major contributor, to so much chronic disease, insulin resistance, type 2 diabetes, heart disease, many cancers, even Alzheimer's.
So the simple message is eat less. But it can't be that simple, can it? What about protein? People worry about losing muscle if they cut back too much.
That's a crucial point. Yes, for most people, reducing overall calories is necessary. However, it's equally important not to restrict protein, especially as you get older, say over 50 or 60.
Why specifically then?
Because of something called anabolic resistance. As we age, our muscles become less responsive to the protein we eat. We need more protein just to maintain, let alone build, muscle mass compared to when we were younger. And losing muscle mass, sarcopenia, is a huge driver of frailty, loss of independence, and even mortality. So the strategy isn't just eat less. It's eat less energy, but maintain or even increase protein. Aiming for maybe 1.0 to 1.2 grams of protein per kilogram of your ideal body weight is a good target for older adults.
Okay, so protect the protein. How do people actually achieve eating less energy? What are the main strategies?
There are basically three main approaches people use. One is classic calorie restriction, consciously tracking and reducing your daily calorie intake. Another is dietary restriction, maybe limiting certain food groups, like cutting out processed carbs or sugars.
Right.
And the third, which has gained a lot of traction, is time-restricted eating, or TRE.
Like intermittent fasting.
Sort of, yeah. It's about confining your eating to a specific window each day, maybe 12 hours, 10 hours, or even 8 hours. So you might eat only between, say, 8 a.m. and 6 p.m. A key part of this is avoiding late-night eating, especially after maybe 9 or 10 p.m.
Why is eating late so bad?
Studies show it can mess with your circadian rhythms, negatively impact your gut microbiome overnight, and significantly worsen insulin sensitivity the next day. Your body just isn't primed to handle a big meal late at night.
Got it. And beyond quantity and timing, what about quality? We keep hearing whole, fresh, plant-based foods.
Yeah.
Why is that so consistently emphasized?
Because quality is paramount. Think of food as fuel. You wouldn't put low-grade fuel in a high-performance car.
Definitely not.
Same for your body. Prioritize whole, fresh, plant-based foods. And the distinction between minimally processed and ultra-processed is absolutely critical here.
What's the difference, really?
Minimally processed might be cooking pasta from flour and eggs yourself, or chopping up vegetables. You're altering the food, but it's still recognizable. Ultra-processed foods, these are different beasts. They're industrial formulations.
Like stuff from factories.
Exactly. Often extruded, loaded with chemicals, emulsifiers, stabilizers, artificial flavors, colors, excessive sugar, unhealthy fats, salt. They're designed to be hyperpalatable, but they often wreak havoc on your gut microbiome, spike your blood sugar, and drive inflammation. Focusing on single ingredient, whole foods floods your body with fiber, vitamins, minerals, and those amazing polyphenols, basically. Mother Nature's pharmacy.
Okay, that makes sense. Fuel your body well. Now, shifting gears slightly, I've heard some interesting things about boosting metabolism through less obvious means, like cold plunges. How does that work? And are there any foods that can do something similar?
Yeah, the cold plunge thing is fascinating. It works primarily by activating brown fat.
Brown fat, not the regular white fat.
Right. We have small amounts of this special brown adipose tissue, or BAT. Unlike white fat that just stores energy, brown fat is packed with mitochondria, those mitochondria again. And its job is to burn calories to generate heat.
So it's metabolically active fat.
Highly active. When you expose yourself to cold, like in a plunge or even a cold shower, your brown fat lights up, starts burning fuel, including breaking down harmful white fat, and it also seems to lower inflammation.
Cool, pun intended. Can food do that?
Interestingly, yes. Certain foods and beverages, again thanks to their specific polyphenols, can also activate brown fat. Green tea is a great example. Its catechins, especially EGCG, have been shown to stimulate BA. Coffee, with its chlorogenic acids, might have a similar effect.
So my morning coffee might be lighting up my brown fat.
It might be giving it a little nudge, yes. It's likely a subtle effect, but potentially a consistent one if you consume them regularly. It's another layer of how diet influences metabolism beyond just calories.
Okay, let's talk supplements. It's a huge industry, often confusing, feels a bit like the Wild West sometimes. What's the real deal? Do any actually move the needle for longevity?
You're right to be skeptical. The supplement world can be very slippery, sometimes outright dirty. There's often very little hard, high-quality evidence for the grand claims made for many products. A lot of the time, taking a handful of pills just gives you expensive, well, enriched urine.
Right.
Your body just excretes what it doesn't need or can't absorb. However, that doesn't mean all supplements are useless. There are a few targeted ones where the data is pretty solid, especially for addressing common deficiencies.
Like what?
Vitamin D is a big one. A huge portion of the population, especially in northern latitudes, is deficient or insufficient. And despite some confusing trial results, often due to poor study design maintaining optimal vitamin D levels, maybe around 40 to 60 ng/ml, seems critical for bone health, immune function, mood, and more.
Okay, vitamin D. What else?
Magnesium. Many modern diets are low in magnesium, and it's involved in hundreds of biochemical reactions. There are different forms. Some, like citrate, are better for regularity. Others, like glycinate or thronate, might be better absorbed for cellular function or brain health. Omega-3 fatty acids, particularly EPA and DHA from fish oil or algae, have strong evidence for reducing inflammation and supporting cardiovascular and brain health.
So, targeted deficiencies or specific needs. What about general health boosters like greens powders or specific probiotics?
Some experts do use them strategically. Peter Attia, for instance, has mentioned taking AG1, a greens powder, sort of as an insurance policy, a belt and suspenders approach to cover micronutrient bases. William Line takes specific probiotics like Lactobacillus reuteri, which is interesting. It's found in some sourdoughs and Parmesan cheese and may even help fight cavity-causing bacteria and also Akkermansia, which we talked about.
But how do they view them? As magic bullets?
No, absolutely not. They typically view them as a top-off to an already healthy whole food diet, not a replacement for it. The foundation has to be real food. Supplements are for plugging specific gaps or providing a targeted boost based on individual needs and data, ideally testing, not just guessing.
That makes sense. Food first. And this brings up a bigger issue, doesn't it? The actual food we eat today might be less nutritious than it used to be because the soil it's grown in is less healthy.
That's a profoundly important systems-level point. Soil health is human health. Conventional agricultural practices, heavy tilling, monocropping, reliance on synthetic fertilizers and pesticides have degraded soil quality significantly over the last century.
How does that affect the food?
Degraded soil, lacking rich organic matter and microbial diversity, simply produces less nutrient-dense plants. Fewer vitamins, fewer minerals, fewer beneficial phytonutrients. And then, of course, the animals eating those less nutritious plants are also less nutritious. It's a chain reaction.
Is there a solution to that?
There is, and it's gaining momentum. Regenerative agriculture.
Regenerative ag, what does that involve?
It's a whole suite of practices focused on rebuilding soil health. Things like no-till or minimal tillage, using cover crops to protect the soil and feed microbes, diverse crop rotations, integrating livestock back onto the land in a managed way, all while minimizing or eliminating synthetic inputs.
And how does that help?
Healthy soil, rich in organic matter, acts like a sponge for water, reducing runoff and erosion. And critically, it sequesters huge amounts of carbon dioxide from the atmosphere, storing it long-term in the soil.
So it's good for climate change, too.
Potentially massively good. Some analyses suggest that scaling up regenerative agriculture globally could sequester more carbon than electrifying the entire global transportation grid.
Wow.
So you get this incredible double benefit, much more nutrient-dense, healthier food for us, and a powerful natural tool to combat climate change. There are definitely challenges in scaling it up and shifting the whole system, but the potential for both human and planetary health is just immense. It reframes farming as ecosystem regeneration.
From the soil right up to our cells, it really is all connected. Okay, so we've talked nutrition, gut health. Let's move to exercise. I've heard you and others say it might be the single most potent thing we can do for our biological age, like the #1 intervention.
I truly believe that, and the data backs it up. If you look at all the things we can do, exercise consistently comes out on top for reducing all-cause mortality, your risk of dying from anything. We're talking maybe a 3-fold reduction for active people versus sedentary. And the impact on specific diseases, like reducing cancer risk by maybe 50% for older active adults, is just profound.
3-fold reduction in dying from anything. That's huge. And you mentioned biological age. How does exercise affect that?
This is one of the most exciting findings. As far as we know, based on current science, exercise is the only intervention that has been demonstrably shown to lower your biological age, as measured by epigenetic clocks.
Epigenetic clocks, those DNA methylation markers.
Exactly. These clocks look at patterns of methyl groups attached to your DNA, which change predictably with age and seem to reflect the functional age of your cells and tissues, often better than your chronological age. Regular exercise literally seemed to turn back that clock, widening the gap between how old you are on your birth certificate and how old your body is functionally behaving. It's a true anti-aging intervention at the cellular level.
That's incredible. And it's not just about cardio, right? Not just running or cycling. Resistance training is key too.
Absolutely essential. Aerobic exercise is fantastic for your heart, lungs, endurance, metabolic health. But resistance training, lifting weights, using bands, body weight exercises is equally crucial, maybe even more so as we age, for maintaining muscle mass, building strength, improving bone density, maintaining balance, and preserving good posture.
Why is strength so important for longevity?
It's fundamental for functional independence. Strength helps prevent falls, which are a major cause of disability and death in older adults. It allows you to continue doing daily activities, maintain your quality of life, and it has profound metabolic benefits too, like improving insulin sensitivity. The evidence supporting strength training for health span is just rock solid now.
Okay, so we need both cardio and strength. For someone listening who wants to start or maybe step up their game, what's a reasonable minimum target? What should we aim for?
A good baseline goal for most adults is to aim for at least 30 minutes of constant motion that gets your heart rate up at least 5 times a week.
Constant motion, like brisk walking.
Brisk walking, jogging, cycling, swimming, dancing, anything that gets you moderately breathless, where you could talk but maybe not sing comfortably. That's zone 2 cardio for many people.
Okay, 30 minutes, 5 times a week. What about strength?
Aim for strength training at least 2, ideally 3 times per week, hitting all the major muscle groups. This doesn't have to mean hours in the gym. It could be bodyweight exercises at home, squats, lunges, push-ups, planks, using resistance bands, or, yes, lifting weights if you have access and enjoy it. And don't forget balance work.
Like standing on one leg.
Seriously, yes.
Yeah.
Simply practicing standing on one leg for 30, 60 seconds at a time, maybe while brushing your teeth, is great for balance and stability.
The best news here seems to be that it's never too late, right?
Absolutely never too late. The benefits kick in regardless of when you start. Even if you begin exercising seriously in your 70s or 80s, you will see significant improvements in strength, balance, cardiovascular health, and overall health span. It's truly the closest thing we have to a longevity miracle drug.
Okay, that's powerful motivation. Now, another pillar that often gets shortchanged in our busy lives, sleep. It feels like the first thing to go when we're stressed or overwhelmed. How big of a problem is lack of sleep?
It's a massive public health crisis, honestly, even though we often treat it like a personal failing. The stats suggest about 1 in 3 adults consistently doesn't get enough sleep. And sleep is it's foundational. It's like the Swiss Army knife of health.
Swiss Army knife.
Yeah, whatever problem you're facing, physical health, mental health, performance sleep usually has a tool in its kit to help address it. Its importance is just impossible to overstate.
And the consequences of skimping on it are pretty severe, both short-term and long-term, aren't they? Even just a little bit of sleep deprivation can make you feel almost drunk.
That's a good analogy.
Right.
Mild sleep deprivation significantly impairs judgment, reaction time, decision-making, very similar cognitive effects to alcohol intoxication. It also makes it much harder to consolidate memories, to learn new things.
And it affects our food choices too, right? Makes us crave junk.
Oh, definitely. When you're sleep deprived, your hormones regulating appetite go haywire. Ghrelin, the hunger hormone, goes up. Leptin, the satiety hormone, goes down. You get intense cravings, especially for high-calorie, sugary, fatty garbage food.
And the metabolic impact.
It's profound and immediate. There was a classic study showing that just 1 week of restricting sleep to 4 hours a night reduced participants' ability to dispose of glucose to clear sugar from their blood efficiently by almost 50%.
50% in 1 week. That's terrifying.
It's a direct pathway toward insulin resistance and type 2 diabetes. And long-term, the links are undeniable. Chronic insufficient sleep is clearly causally linked to increased risk of cardiovascular disease and Alzheimer's disease. The link to cancer is maybe a bit less definitive, but for heart and brain health, it's absolutely solid. Sleep is not optional downtime. It's essential maintenance.
It's still amazing to think of sleep as this active repair process for the brain, not just passive rest. What's actually going on up there while we're unconscious?
It's an incredible, highly active process. During deep sleep stages, your brain activates what's called the glymphatic system. Think of it like the brain's dedicated sanitation crew.
Brain sanitation.
Exactly. Tiny channels open up between brain cells, allowing cerebrospinal fluid to flush through and wash away metabolic waste products that accumulate during waking hours. This includes toxic proteins like amyloid beta and tau, the ones implicated in Alzheimer's.
So sleep is literally cleaning your brain.
It's cleaning out the junk, yes. If you consistently shortchange sleep, that cleaning process is impaired, and these toxic proteins can build up over time. Sleep also plays a huge role in regulating metabolism and stress hormones like cortisol. Chronic sleep deprivation leads to elevated cortisol, hypercortisolemia, worsens insulin resistance, both of which are bad news for your heart and your brain.
Okay, it's clearly non-negotiable. So practically, what should we be aiming for? How do we optimize our sleep?
First and foremost, prioritize the time. You really need to allocate about 8 hours in bed each night. That allows for roughly 7 to 8 hours of actual sleep, accounting for time to fall asleep and brief awakenings. Many people simply don't give themselves this window.
Schedule it like an important appointment.
Exactly. Second, consistency is king. Try your absolute best to stick to a regular sleep-wake schedule, even on weekends. Avoid that social jet lag where you stay up late and sleep in on Saturdays and Sundays. That really messes with your internal body clock, your circadian rhythm.
Right, keep the rhythm steady. What about the environment?
Optimize your sleeping chamber, your bedroom. Make it cool. Cooler temperatures help signal your body it's time for sleep. Make it dark. Pitch black is ideal. Use blackout curtains, cover LEDs, and make it quiet earplugs or white noise if needed. Cold, dark, and quiet. Those three things make a huge difference to sleep quality.
Cold, dark, quiet. Got it.
Right.
So we've covered a lot of the physical, the biological stuff, but true health span, holistic longevity, it's more than just biology, right? Let's talk emotional health, stress management. I heard something surprising about happiness actually increasing as we age.
Yes. It's called the U-curve of happiness. And it's a really fascinating finding from social science that pushes back against the narrative of inevitable decline.
The U-curve, how does that work?
Basically, studies across many cultures find that reported life satisfaction tends to dip in middle age, often bottoming out somewhere in the late 40s, like maybe 47.2 years old on average in some studies.
Midlife crisis point.
Perhaps. But then after that point, happiness levels tend to steadily increase through the 50s, 60s, 70s, often peaking quite late in life, maybe only leveling off in the very final years.
So people generally get happier after 50?
That's what the data suggests. It's counterintuitive to the over-the-hill narrative, isn't it? It likely reflects shifts in perspective, priorities, maybe increased wisdom, gratitude. It's a very hopeful message for our later decades.
That is hopeful. And we know there's a strong link between physical and emotional health, right? Feeling physically unwell can definitely make us feel emotionally worse.
Absolutely. It's completely bidirectional. If you're dealing with chronic pain, fatigue, poor sleep, even a simple deficiency like low vitamin D, it absolutely impacts your emotional resilience. You might be more irritable, anxious, have lower mood. Sometimes addressing the physical root cause can significantly improve the emotional state.
And what about stress itself? How does chronic stress act as this master switch affecting our physical health?
Well, acute stress, the fight or flight response, is normal and protective. But chronic stress, when that system is constantly activated, triggers a cascade of harmful physiological changes. It keeps your blood sugar elevated, contributing to insulin resistance or what some call toxic diabetes. It raises blood pressure. It can keep your amygdala, your brain's threat detector, in a state of hypervigilance, leading to chronic anxiety. It's like keeping the engine revving in the red zone all the time.
So we need to manage the distress, not necessarily eliminate all stress, because a life without any challenges would be pretty dull.
Precisely. The goal isn't a stress-free life. That would be unfulfilling. It's about increasing our distress tolerance, our ability to handle challenges without becoming overwhelmed or physiologically derailed.
And you mentioned exercise helps with that.
Exercise is fantastic for distress tolerance. It helps regulate stress hormones like cortisol, improves neurotransmitter balance, and builds mental fortitude alongside physical strength. And other practices can help too, like cold exposure.
Cold showers again.
Yeah, even just ending your shower with 30-60 seconds of ice-cold water can powerfully stimulate your vagus nerve and activate the parasympathetic rest and digest system, helping to calm you down and reset your stress response. It builds resilience over time.
What about those deeper patterns, though? Things like self-sabotage or being a relentless perfectionist. Those seem harder to tackle with just exercise or cold showers.
For those deeper, often ingrained patterns, yes, more intensive work might be needed. Things like therapy, CBT, DBT, psychodynamic therapy, or dedicated self-reflection practices can help uncover the roots of those behaviors, understand why they developed, and start to rewire those responses. It's about changing the mental software.
And avoiding the perfection trap.
Absolutely crucial. Remember the mantra, perfect is the enemy of good. Trying to fix everything at once is overwhelming and often leads to giving up entirely. Just pick one small, manageable thing you feel confident you can achieve today or this week. Build momentum with small wins. Consistency beats intensity when it comes to sustainable change.
That idea of small wins resonates with the next piece. Social connection and purpose. These seem just as vital as diet and exercise, maybe even more so in some ways. Social isolation is terrible for health.
It's incredibly detrimental, yes, both mentally and physically. We are fundamentally social creatures. That human bond, that sense of belonging, is something technology or AI will simply never replace. It's a basic human need.
And we see this reflected in the blue zones, right? Those places where people live extraordinarily long, healthy lives.
Exactly. When researchers looked at the common factors across these diverse regions, Okinawa, Sardinia, Ikaria, Nicoya, Lomeland, strong social connection was a universal theme. They have tight-knit communities, like the Moai support groups in Okinawa that last a lifetime. Strong, multi-generational family structures are common.
And purpose.
And a clear sense of purpose, yes. The Okinawans call it ikigai, your reason for waking up in the morning. In Nicoya, it's plan de vida, or pura vida, a life plan, a pure life philosophy, having meaning, feeling needed, contributing to something larger than yourself. These are powerful drivers of longevity and well-being.
It makes sense, although it also highlights challenges like the immense stress on caregivers who often pour everything into others and neglect their own well-being.
That's a critical point. The caregiver burden is real and can take a huge toll. It underscores the need for self-care not to be seen as selfish, but as essential for sustainability, both for the caregiver's own health and their long-term ability to provide care. You should put on your own oxygen mask first.
Absolutely. And these principles, managing energy, stress, having purpose, strong connections, they don't just apply to biological health, do they? They seem fundamental to sustaining any demanding endeavor long-term, like a career or family life.
Completely. The same principles that support biological longevity are the ones that support longevity and resilience in your work, your relationships, your service to others. It's about managing your energy, setting boundaries, staying aligned with your values, and nurturing your support systems.
We see this clearly in demanding professions. For example, hearing from people with decades of experience in service roles like ministry or counseling. Eli Gutierrez, who's been in ministry over 30 years, really emphasizes that who you are at home, your character behind closed doors, is paramount for long-term effectiveness.
More so than public image.
Way more so, he argues. The disconnect if someone is praised publicly but is, say, harsh with their family or neglectful, that hypocrisy eats away at you and hurts those closest. Authenticity is key for sustainability.
That makes perfect sense. Internal alignment.
And boundaries come up again and again. The importance of scheduling family time, personal downtime, and sticking to it. Realizing You can't be available 24/7 to everyone without burning out or damaging your core relationships. Not trying to take Jesus's place, as one person put it.
Setting limits is an act of stewardship of your energy, your health, your primary relationships. It's not selfish. It's necessary for long-term service.
And dealing with imperfection. Acknowledging that questioning your path, having doubts, making mistakes, that's normal. The advice often given is, you are not worthy through performance. You will never be perfect. Apply the same grace to yourself that you preach or offer to others.
Self-compassion. Avoiding that cycle of condemnation and shame. Learning from falls instead of being defined by them. That righteous person falls 7 times yet rises again. It's about resilience fueled by grace, not perfectionism.
Right. Conviction leads to growth. Condemnation leads to despair. And finally, this idea that not every season needs to be public or on stage. The importance of seasons of hiddenness and preparation.
That's really profound. Just like roots growing deep before a tree bears fruit. Periods of quiet learning, reflection, internal development are often essential for building the foundation for sustainable, meaningful impact later on. It's not all about constant visibility.
Building that internal foundation. Okay, so wrapping this all up, synthesizing this incredible deep dive today, the core message seems to be that longevity, true health span, is this multifaceted thing. It's biology, yes, but it's also lifestyle, emotional health, social connection, purpose, all interwoven. It's not about finding one magic pill or a quick fix. It's about consistent, intentional choices across all these areas.
And what I find so incredibly empowering about all this is that you are not simply doomed by your genetics. Yes, genes play a role, but your lifestyle choices, what you eat, how you move, how you sleep, how you manage stress and connection, have a profound impact on how your genes are expressed and how you age.
We have agency, significant agency. The science strongly suggests we are all fundamentally hardwired to actually heal. Frailty, chronic disease. These are not inevitable consequences of aging for most people. We can significantly influence our health trajectory.
But with so much information, all these different pillars, it can feel overwhelming. Where does someone even start?
That's a common feeling. And the advice often given, which I think is excellent, comes from Peter Attia. Just pick one. Don't try to overhaul your entire life overnight. That's a recipe for failure.
Right.
Look at all these areas: nutrition, exercise, sleep, stress, connection, and just pick one thing you feel you can realistically implement and succeed at today or this week. Maybe it's adding one more serving of vegetables. Maybe it's going for that 30-minute walk. Maybe it's putting your phone away an hour before bed.
Small wins build momentum.
Exactly. Consistency with small, achievable changes is far more powerful in the long run than attempting huge, unsustainable transformations. Build confidence, then add the next small thing.
That's great practical advice. Okay, final thought to leave our listeners with, something to ponder.
Well, here's something interesting. When you talk to people who are truly in their later years, maybe reflecting from their last decade of life, and you ask for their wisdom, a common piece of advice you hear is often surprisingly simple. Do less.
Do less, not do more.
Do less. Which is fascinating, isn't it? It's not about laziness, I think, but about a profound reevaluation of priorities. It makes you wonder, and this is the question for everyone listening, are you truly prioritizing what matters most for a long, well-lived, vibrant life? Or are you maybe too caught up in the frantic, constant urgency of the day-to-day?
Sacrificing the important for the urgent.
Perhaps sacrificing deeper well-being, connection, or even health for things that feel immediately demanding but might not hold lasting value. What will your 80 or 90-year-old self genuinely thank you for having done or prioritized? And what might that future self regret you chased instead? This deep dive was about exploring the science, yes, but also the art of living well for longer. The choices ultimately are yours to make.